All right, this is 1-1B. You can go ahead and do the warm-up on your own. We are doing levels of measurement. So you have data and you can figure out how specific that data is based on what kind of level it's at. And there are nominal, ordinal, four levels. Nominal, ordinal, interval, and ratio in that order. Okay, so nominal is the lowest, then ordinal, interval, and then ratio is the highest level of measurement. So I'm going to tell you what they are and then give you examples of each one. So nominal is in name only. Okay, so you have this data and you know the name of things. So you split things up by color. Okay, like this many kids are wearing blue, this many kids are wearing purple, whatever it is. So nominal is by name, and that there's no order to it. There's nothing that says one is better than the other. It's just categories. Okay, so name or categories. Just splitting things up. Ordinal has an order, just like it sounds. Okay, but the order doesn't necessarily have the same distance between things. It's like this one is bad, this one is good, and this one is excellent. Okay, you know which one's better than the other. There's an order. You'd put the bad, then the good, and then the excellent. But there's nothing specific that says this makes it bad, this makes it good. Like the distance between good and bad and excellent or whatever is not consistent. So there's an order, but you don't know. There's no numerical values, really. Interval, there are numerical values, but there's no starting point. And we'll talk about this. These are the hardest ones to tell apart. Okay. And a ratio has a starting point. Okay. So we'll talk about that as we go. So nominal is the lowest level, means in name only. So nominal is name, and there's no other criteria. You're just splitting things up into categories. So these are just the names of Native American pueblos from the population. You're just splitting them up. Just name, name, name. Doesn't say one's better than the other. They're in no order. They're just split up by categories. Okay, then an auto dealership has a new supply of trucks. The colors are red, white, silver, blue, and black. Nothing says that one is better than the other. It's just the way it is. These are the colors. They're split up by colors, but there's no orders of the colors. So that's just straight up nominal. Now, ordinal, they have an order, but the value differences are not determined, or they're pointless. There's no really numerical value to them. So it says a high school graduation class of 319 students. Jim ranked 25th, June is 19th, Walter's 4th, and Julia 10th. Now, you got to be careful with this because you have to think about what's causing these rankings and then think about that specifically. So you could obviously put them in order. You know who's 1, who's 2, 3, 4, and so on. But what causes those orders, okay? So those orders are determined by GPA, right? GPA makes the order. But there's nothing that says that the difference in the GPA between spot 1 and spot 2 is 1/10 of a point, and spot 2 and spot 3 is 1/10 of a point. Like the distance between those GPAs for 1 and 2 and 3 are not consistent, okay? 1 and 2 could be 1/100th of a point apart, but then 2 and 3 could be 3/10 of a point apart. Like there could be a big gap and different distances between 1 and 2 and 3, but you should still put them in an order, but what determines that order isn't consistent. Okay, and then it says in a catalog there are 17 fishing reels. Some were good, some were better, and some were best. Again, good, better, best. You know, it's like the star system, right? Like a movie has 2 stars, 3 stars, 4 stars, but what causes those rankings, what's actually behind that isn't really any kind of true numerical values. It's just the way it is. So there's nothing that specific that separates them. So that's just going to be ordinal. You can put them in an order. You know which one's better than another, but there's no numbers backing it up. Interval is similar, but there are meaningful differences between the values. So you're basically measuring in something that's consistent. So you're measuring in like years or inches or minutes, okay? Something that is very concrete and you know that the distance between all those things is the same. But the difference between interval and ratio is that interval doesn't have a specific starting spot. So basically it can be negative, it can slide around, there's no distinct starting point. So, years in which Democrats won presidential elections. There are years are specific, you know the distance between 1, 2, 2, and 3 years is all the same. Okay, so your measurement is something specific, so you're at least at the interval level. However, there's nothing that says it has to start now. There's no specific starting point for that, for the years, so that one it has to be interval. It doesn't get to jump up into ratio. Body temperature of trout swimming in the Yellowstone River, so degrees Celsius, there's a distinct difference between 1 and 2 and 2 and 3 degrees Celsius. That's a specific measuring tool. But temperature can be negative, and there's nothing that says it has to start at this temperature, so that's going to be interval. Whereas ratio has an inherent zero, it has a starting point. It basically, the easiest way to tell is like it can't be negative. There has to be something that says it starts right now. So it says the time lapse between the deposit of a check into a bank account and the clearance of the check, 6 days versus 3 days. So we're measuring in days. We all know that days are the same length. Okay, so days is a just definite level of measurement. You have something specific you're measuring. So you're at least at interval. Now you have to decide if you can jump up to ratio, and the way you jump up to ratio is by having a distinct starting point. A check cannot clear before you deposit it. Like you deposit it and then the time starts. So that has to have a starting point. The starting point is when you deposit the check. So that one has to be ratio. The length of the trout swimming. So we said that the temperature couldn't be ratio because temperatures can be negative. Length, for one, you're measuring something specific. You're measuring in inches, so that's already at the interval. It gets to jump up to ratio because length can't be negative. Either the trout exists or it doesn't exist. So the fact that it can't be negative and that it has a distinct starting point makes it ratio. Okay, 1-1B.